Hello, I'm Ryan with High Desert Math Tutor, and today I want to take a moment to show you how to solve rational equations. So anytime we're working with rational equations, or just rational expressions even, we always want to figure out, are there any values that we are not allowed to plug in to these rational expressions for x? And the only thing that you have to worry about with rational expressions in general is dividing by 0. So we have to make sure we identify what values for x could cause each of these denominators to become 0. So this is a nice example because if you notice, each denominator is already in factored form. So initially, when you're solving for restricted values or values that would make the denominator 0, you start by factoring each denominator. And after you factor each denominator, you want to set each factor in the denominators equal to 0. And I'm going to actually say that these factors are not allowed to equal 0. So since right here we're dividing 1 divided by x is not allowed to be 0. Here we have x plus 3. We're dividing 3x by x plus 3. So x plus 3 is not allowed to be 0. And here, if you notice, we have two factors in this denominator because there are two things that are being multiplied. Each of these factors we already have, so we don't need to do anything with this denominator. So after you set each denominator equal to 0, we solve for x. So we see here, x is already by itself, so we can clearly see x is not allowed to be 0. Here, we need to do a little work to get x by itself. So we can start by subtracting 3 from both sides, canceling that, and we see x is not allowed to be -3. So these are two values that are restricted. We are not allowed to use these. So if we wanted to, we can go ahead and state the domain of this entire equation. So we can say that in 3 different forms. Let's first give interval notation. So in interval notation, we can plug in any value, even positive, negative, as long as this value is not equal to -3. We can plug in values between -3 and 0 as long as we're not equal to either of those. And we're allowed to plug in any value that's greater than 0. So that would be the domain in interval notation. I hope you can see, I know it's a little bit small. So if we were going to give inequality notation, what we would have is this. X could be anything that's smaller than -3, or x could be anything from -3 to 0, or x can be anything that's greater than 0. So those are two different ways to state the domain. So quick refresher, the domain is all values that we are allowed to plug in for x. So now that we see the domain, more clearly we can see the two values we have to avoid. Now we'll just quickly get to solving this rational expression. So when you're solving a rational expression, you first ask, are there any values I avoid? Because I'm going to have to check those against my final answer before officially deciding what the answer is. The second thing we do is we look at the entire equation and we look for what would make up the least common denominator. So for the least common denominator, the LCD, that's going to be equal to the product of all factors that make the denominator. So you see here, in this denominator, we have an x being multiplied and we have an x plus 3 being multiplied. We have two factors. In this denominator, we do not have an x by itself, but we do have an x plus 3. In this denominator, we have an x, but we do not have an x plus 3. But it looks like everything that we're using to build all three denominators consists of simply x and x plus 3. So once we identify what the least common denominator should be, we can actually make our lives much easier by getting rid of these denominators by multiplying both sides of the equation by the least common denominator. So I'll show you what I mean in just a moment. So if we multiply both sides by what we've just said is the least common denominator, we're going to multiply by x times x plus 3, x times x plus 3. I'll go ahead and put these in brackets. And we need to distribute over here. We have two terms, so we need to distribute this product into, or these factors into the parentheses. So we see here, I'll show all the work, we're going to have x times x plus 3 times 1 over x minus this again, x times x plus 3 times 3x divided by x plus 3. And on this side, we're actually set to do something very nice. So notice we have x minus 24 divided by x times x plus 3. Well, we're dividing this by x times x plus 3, and on the right side, we're multiplying by x times x plus 3. So whenever you multiply something and divide it by the same factors, those factors completely cancel each other out. And all we have left over here is just x minus 24. But that same idea is what's going to make this much nicer for us in just a moment. So over here, we're multiplying x plus 3 times x. Here, this is the same as 1 divided by x. So these x's cancel each other out. Technically, we have x plus 3 times 1, but then anything times 1 stays the same. So this is just x plus 3 right here. Minus, now over here, we have x times x plus 3 times 3x divided by x plus 3. So we have a common factor of x plus 3 in this being multiplied, a factor of x plus 3 that we're dividing by, so these cancel each other out. And all that's left over here is x times 3x. That whole thing is equal to x minus 24. Now we can combine this a little bit more, so we'll take the x plus 3, just bring it over, minus x times 3x is 3x squared. Copy this down. And now what we can do is actually start solving this equation by first setting one side of the equation equal to 0, factoring the other side, and then finding out what values for x make this equation true. But to give you context, we notice that the highest power on x in this equation, the highest power on x is 2. That means this equation is currently a quadratic equation. And the way that I know that we want to set one side equal to 0 is anytime you're solving a quadratic equation for a certain value of x, you want to make sure that you set one side equal to 0 so you don't lose any information from the problem. So since this x squared is negative, I know it'll make life easier if we make this positive by getting rid of the 3x squareds on this side. So what we can do is get rid of the 3x squared by adding 3x squared to both sides. We can get rid of the x by subtracting x from both sides. And we can get rid of the 3 by subtracting 3 from both sides. So that cancels, that cancels, that cancels, and there's nothing left. So what number represents nothing? 0. But over here, we don't have any x squareds, so when we add 3x squared, that's all we get for the x squareds. We have an x, but we're also subtracting an x. So these actually cancel each other out. And then we have minus 4, we're also subtracting, oh, sorry, that's not just 4, that's minus 24. We're also subtracting 3, which means we have negative 27. So we have 0 on one side of the equation, everything else on the other side. And as I said before, what we want to do is take this thing and we want to factor it completely. So first, we can factor out the greatest common factor. So this term has an x, this has no x's. So that means there are no variables in the greatest common factor. This has a 3, and 27 is the same as 3 times 9. So the greatest common factor is 3. What's left over is x squared minus 9. And now for the final factoring, this is quadratic still. So whenever you factor something that's quadratic, you generally have 2 sets of parentheses. And this is called the difference of squares. So when you have something like x squared minus 9, you might notice that you could rewrite this as x squared minus 3 squared. Because what is 3 to the power 2? 3 times 3, which is 9. So whenever you get this, which is called the difference of squares, this is called a special factoring case. What this turns into is x plus 3 times x minus 3. It's not very obvious, and you can prove this pretty easily, but that's something that's worth committing to memory, is this pattern where when you have two things that can both be written as squares and you're subtracting them, that's called the difference of squares. And you simply say x plus what number you have to square times x minus whatever number you have to square to get 9. So we can substitute that in here, x plus 3, x minus 3, and now we've fully factored this right side of the equation. So we're one step away from being done. So to solve an equation means to find what x values makes this side of the equation equal or have the same value as this side. If you do the correct steps for algebra, you can manipulate this equation into anything you want and still find the x values that satisfy the original equation. So we've gotten to the point where we need to figure out what makes this side turn into 0. And we have 3 factors that can help us do that. So here's one factor, here's the second factor, here's the third one. So this first factor of just 3, we can't do anything to that. That's just the number 3. So that one doesn't necessarily help us make this equation true. But the second factor has an x in it. If we could find what value of x makes this whole factor become 0, then 0 times anything equals 0. Similarly, there's an x in this factor, and if we could figure out what x has to be to make this factor equal 0, 0 times anything equals 0. So separately, we will take each of these factors, set them equal to 0, and solve for x. And those values are the values for x that should make this equation true. So the first one, right here, we have x plus 3 from right here. We want that to equal 0. And over here, we have x minus 3. We want that to equal 0. So when we solve each of these for x, we're going to have to subtract 3, add 3, add 3. What we get as answers is that x is negative 3, makes that factor equal 0. X equals positive 3 makes this factor equal 0. So these are the 2 possible solutions for the original equation. Now both of these values make this true. That's clear, I hope. But these are not guaranteed to be the solution to the original equation until we compare these values to the values that are restricted. So we can see the 2 values x is not allowed to equal. X is not allowed to equal 0, and x is not allowed to equal -3. But notice here, one of the possible answers we got was x equals -3. This one is not allowed. And the reason for that is it is what we call an extraneous solution. So an extraneous solution is a solution that you're not allowed to use, but you obtain that solution through doing correct algebra. And what makes a particular value extraneous is that it's a value that is not in the domain of the original function, of any part of this original function. So the last thing I want to point out is what does extraneous mean? Well, if you notice, extraneous literally has the word extra. So an extraneous solution is an extra solution we've gotten from doing correct algebra, but we're not allowed to use this because it's not in the domain of the original function. So I hope that's useful. Just remember the most common mistake people make when solving rational equations, when they know the process, this process, the most common mistake people make is they forget to check the final answer for extraneous solutions. And that's because people get in the habit of jumping into doing the algebra without first finding the domain, or as bare minimum, finding what the restricted values are, what you're not allowed to use. So just make sure that when you're looking at problems that involve solving rational expressions or rational equations in particular, make sure that you build the habit of first finding the restricted values, stating the domain, and then before you move on from the question at the very end, make sure that you check your possible solutions against those restricted values.